Thank you so much. Appreciate it. Hi, everyone. Music. Beautiful. Music to my ear. Hi, everyone. I'm going to talk to you about some experiences that we've had in academic work, but I just want to make sure that it's clear that this is not representing Google's perspective per se. I represent Google's perspective on the technical side all day long. This is different. It's a hiatus from that. Just want to set expectations. This is not a Google position that I'm presenting. This is actually several components to this presentation. We have a new economic reality where the model of software as a service or software as a service economy is kind of trailing behind now. And a newer AI economy is defined by a very high variable, physically constrained marginal costs. And this is actually one of the most significant events that has happened in recent history. There's an unprecedented capital cost associated with AI. So by some estimates, there's about $7 trillion of cumulative CapEx just on data centers. And so there's a macroeconomic force that is driving this shift of this industrial investment that outweighs a lot of other very traditional economic drivers. A lot of this computing cost is baked into this number, and a lot of the other parts of the cost, maybe 2/3 of it is in computing, but the other 1/3 is in power and real estate, putting up data centers and consuming power for AI. So these are considerations in the equation of what we do with an economy. So we're building essentially an infrastructure to support a technology that is promising, very, very promising. It's on the brink of becoming profitable. But there is a structural mismatch where the revenue from the current users and the effort and economy going into building models and inferencing them is disproportionate. And so assuming that that is a sustainable thing going forward is kind of a fallacy. Where we are is, from a technology perspective, we had very specialized models that did very specific things. We then came up with models that are what are called thinking models. At Google, we've built kind of the frontier models, Gemini family of models. Gemini Pro 2.5 is the latest of these thinking models. They're very capable in doing deep reasoning, planning. It won the Math Olympiad. It got the gold medal at the Math Olympiad. So these types of models are important because currently we're in the agentic space, smack in the middle of this diagram. Agents need really strong planning and reasoning capabilities. They need to know about the world. If it's a supply chain problem, they need to know that a tariff has hit a particular country in a particular geography to look for alternative suppliers or route things differently. And so think Google Maps, right? So the notion of location awareness, understanding a world model is extremely important for these types of large language models. We need active task execution. Agents should be able to do things we delegate them to do. They need to be able to conduct autonomous operation. And they need to negotiate among themselves because agents will get into, just like we do, dissent among ourselves. Opinions are different and diverse, which is great. But we need to come up with a decision among those diverse decisions or observations that are made by the agents, and therefore consensus building, conflict resolution becomes extremely important. Artificial general intelligence and superintelligence, I'm not going to get into too much, but all I am going to say is that when we talk about AGI, this is not some Star Trek kind of thing. It's like, what can I do to help a scientist take tens of years and compress of work that they would be doing in their lifetime and compress it down to a few months so they can be more productive from a science. So We built something called AlphaFold, which takes an input sequence of DNA and maps it into a 3D molecular structure. So now, it would typically take, for each one of these DNA sequences, it would take 2 or 3 years to build these molecular structures. 2 to 3 years. So now we can do that, we've mapped the whole thing. So we can do that in much, much less time. So this allows the scientists to become more productive. So when we talk about artificial general intelligence, we're talking those types of things. So as we move into the notion of agentic AI, we're moving from just obtaining information to actually being able to delegate and taking supervisory action in many of these things. So this will enable a new wave of productivity. This is kind of a McKinsey statement I thought I'd quote. Okay, this is an eye chart, but what this is trying to show is we have 3 agents, 1, 2, and 3. What is this agent thing? Okay, we give the agent some goals. We say, hey, agent, these are my instructions. These are your goals. Go do it. It's going to sense the environment up top left. It's going to sense the physical environment if necessary. The digital environment is necessary, databases, vector database, etc. It's going to sense the environment. You give it instructions. It's going to create, it's going to reason about it. It's going to reason about it, and then it's going to plan. The plan is a set of steps. Those steps are, okay, I can do steps 1 through 5. Let's say, very basic thing, loan origination, okay? Let's say 10 steps. I can do the first 5. I'm not FICO. I have to go to FICO to get someone's credit score when they give permission. So I have to actually look for another agent or a tool, so to speak, in order to get that FICO score. So if it's internal data, I use what's called the Model Context Protocol, MCP protocol, that was developed by Anthropic to get information. And if it is something else, if it's another agent from another company that I need to securely connect to, I need the protocol called the agent-to-agent interoperability protocol. This is something we devised at Google. We've made it open source. It is in the hands of the Linux Foundation. It's not a Google thing. We just thought it's very important for the rising tide to raise all ships, so that in a very vibrant economy, everyone benefits. So agents have to talk to each other. It's like your cell phone. When you're with Verizon or Telstra or Virgin, you need to be able to still call each other on your cell phone. So that's agent-to-agent interoperability. And effectively, that coordination happens so that you can execute a workflow. But this happens through different levels of maturity. You have single-agent systems, level 1. You have multi-agent systems, level 4. You have self-learning systems as a level 6. So there are various ways in which you can skin this cat. You can basically have different levels of sophistication that you need. There are certain capabilities you need in order to get from one level to another. So in this discussion, that's kind of a little bit of a background. I'm going to quickly cover about 10 what we call economic patterns of agentic AI. And so it's going to be fast and furious, so please put on your seatbelts. The first one is digital labor elasticity. So agentic AI, we just defined what agentic AI is, distributed intelligence, agents doing these things. With our supervision, some semi-autonomously, some completely autonomously as we develop more trust with them. This expands the workforce through digital labor. And so labor becomes more of a function of compute. And the implication is that we need to potentially redefine metrics we have in our companies with hybrids, human plus an assistant, an agent, FTEs. And that changes the mindset. So I'm going to pause. If you want to, the takeaways from each of these patterns is that last statement. So if you want to say, okay, what do I do tomorrow? What do I change? If we get into the digital labor pattern a little bit more, it expands the supply of digital labor, agentic AI does, and it pushes the effectiveness of the workforce beyond what I can do, what you can do. It enhances our capabilities. It's like, I'm also a teacher, so it's like I can hire research assistants that way, much faster, very capable research assistants to help me with my work. And so the economic dynamic is that labor becomes more elastic, marginal worker capacity can be scaled with compute rather than just the hiring process. There may be a correlate with hiring. HR, finance, and ops and things like that need to rethink what it means to have a blended model of humans and agents. And so you have new labor cost curves. Pattern number 2 is skill-based augmentation. So again, what I can do and a co-scientist helping me do my job better, I will act more like an agent supervisor. And so we, as the industry and community of people who are using AI, need to think about literacy and skills in an age of agentic orchestration. So we need to be able to orchestrate things better. So in this skill-based augmentation, basically you're going to have skills that are not necessarily, you don't have to have computer skills. Not everybody is going to become a computer scientist. On the other hand, vibe coding or the notion of just putting in a prompt is excellent. It's a good start. But we need to understand the dynamics of how we supervise these agents, how we orchestrate these agents, and we need to gain that literacy. There will be some inequality within firms because some people will know how to do it, some people won't. So we need to do reskilling and think about what would agent managers look like, not just basic AI literacy. The third pattern is workflow recomposition. So an agent, or agentic AI in general, disassembles a workflow. Traditional jobs are streamlined. We need to break them down into tasks, and then those tasks can be reassembled in different ways. Okay, so one of the major things I encounter day to day is many of our partners and customers say, yeah, that's fine. We have a business process in place. It's steps 1 through 10. I'm just going to put an agent instead of a person to do that step. That's a really wrong way to approach the problem, because it's not like the agent and the person are replaceable. It's not the case. So you need to think of what are the tasks that need to be accomplished, and then put people in places where their key decision-making, brain power that we have, ingenuity, creativity that we have, and then leveraging the agents for more of the grunt work, frankly, for more of the repetitive work, more of the deep research that we can then revise. So the idea is that we will be able to decompose jobs into tasks, reassemble them in hybrid workflows, and the metrics will shift from a job level to a task-based set of activities. So occupation level projections, if you will, become slightly less meaningful, and task level economics become more salient and more dominant and will become more prevalent. So things like data collection, what are these tasks? Data collection, coordination, drafting, monitoring. You have agents monitoring a whole lot of things that we can't monitor directly, but when the agents are sending us signals from 50 million different directions, we'll go nuts unless we have a mechanism. We need an assistant, another AI agent, which will help assimilate all these signals coming in from these little minions and assimilate them so that, okay, now I can digest, I can understand what all these signals are. So the human, my assistant, and then the agents who are doing things out there. This is a triumvirate paradigm of 3. We call it the triumvirate paradigm. Human, assistant, and the agents. Agents do a lot of great work, but we have to be able to digest it. Pattern number 4 is compute as labor substitution. So labor cost becomes compute cost. CFOs treat compute, will begin increasingly to treat compute as a workforce capacity. This is a change in paradigms. And so we need to balance efficiency and scalability in terms of compute as labor. So from that perspective, if there's let's say, $1 trillion TAM for digital labor, if you forecast, as an executive, if you forecast the TAM for digital labor, you need to expect consolidation around different labor platforms that manage fleets of agents to accomplish different tasks. So these types of dynamics imply that capital flows will target agentic platforms, but only those that promise recurring productivity gains, are demonstrably showing metrics are being met, and not just one-off automation. The one-off automation is the mindset that I'm going to take a business process and just assign an agent to it, and therefore I don't have to hire people, which is a fallacy. The fifth pattern is usage-based cost inflation. So AI introduces variable cost models per prompt, per workflow, and we need to monitor the unit economics. Basically, how many tokens are you using? Limit the amount of tokens the agent can use so that you don't get a huge bill is the net of it. So this governance is something that we need to be aware of within companies. So strategic leaders should model scenarios where there are classification of different forms of labor, and then the cost of engaging in that labor, the AI cost, like so when you're paying for AI, you're paying for the input tokens, the output tokens, and the actual compute that the actual AI is performing. So that's your total cost. You can limit the amount, it's called a token budget. So for example, at Google Cloud, you can limit the token budget. You can say, it's like a per diem. If I go to another city, maybe my per diem is maybe $50. This is how much you can spend per day on food, let's say, or something like that. So in a similar manner, these are the amount of tokens that you can expend for your agent. So you need to have a provider that can limit those types of tokens in the following way. So pattern number 6 is around complementarity of investment. So basically what this says is you get returns based on the data, processes, and skills. If you underinvest in these types, meaning if you don't give the agent adequate, correct data that is relevant, the agent is going to fail miserably. If you don't direct the AI with proper prompts, with proper with proper data, retrieval augmentation, meaning you pull information. Okay, what's the stock price of company X today? The LLM doesn't know. You have to pull it from somewhere, give it to the LLM, and then ask it a question. So we need to balance augmentation with the reduction of friction as the agent is performing work. Pattern 7 is platform consolidation. What does that mean? It means that agentic AI ecosystems will favor integrated stacks. Today, every provider, ISVs are out there. Everybody does a little bit of things. I'm really good at, this company is really good at this part of agentic AI or LLMs. Another company just produces LLMs. Another produces infrastructure. So the vertically integrated stack is going to be extremely important. Now that means if it's consolidated in one company, great. If not, you as a user of those different parts need to put together a stack for yourself to see which stack favors your company, your infrastructure, your needs. That vertically integrated stack, that's a platform consolidation that you need to be thinking about. One of the things you can differentiate yourself on as you build this or as you utilize this integrated stack is to differentiate your company through domain-specific agents. If you're in finance, if you're in capital markets, if you're in retail, develop specialized agents for retail, for capital markets, with your data that obviously you are eligible to utilize, and tune those agents. Tuning agents, which are smaller models, is not a very costly prospect. You can distill models, you can tune them in different ways, and you can add value to your company. As you're consolidating the platform of the capabilities you need, you create differentiation for your company through that mechanism of domain-specific agentic AI. The 8th pattern is a governance lag pattern. So regulation is going to lag behind. Governance is always going to lag behind, unfortunately. Ethics and responsible AI lag creates a really bad risk. Some companies, so way back when, I work for Google, so I would be asked, hey, Google invented the transformer architecture in 2017. You guys had talked to the transformer. Why didn't you put something out like ChatGPT in November of 2022? So a research company who's a very small, nascent research company at the time can do so with impunity. If they break something, it's no. But if a larger company does so, they're going to get dinged. It's going to be a regulatory nightmare. It's going to be so. One step, one misstep, it's like, what does Warren Buffett say? Is like, it takes 20 years to build a career and 5 minutes to, ruin a career that way. So it's important to realize that some of these larger companies, including Google, have a long process of responsible and ethical AI, go through tons of due diligence, and products just can't be, I was driving up here from Sunnyvale, and I was like, some of these billboards were like, just ship your AI. It's like, right? It's just, what are you talking about? I can't do that, just ship. It doesn't work that way. You have to go through due diligence. You have to go through responsible AI. You have to run multiple tests. And still we fail. Still there are issues. So firms gain short-term arbitrage kind of constraints, but we still face major compliance pressures that are always lagging behind. So we have to be diligent ourselves of proactively going after those constraints that we impose on ourselves so as not to unleash things that are detrimental. And so we need to design ethical, auditable agents that are being monitored and favor platforms that give you the capability to monitor your agents, evaluate your agents, make sure those agents are doing the things that they're supposed to do under the guardrails, under the policy adherence mechanisms that you have in place. Number 9 is real option investment. So what that means is you can think of agentic AI investments as small compounding experiments. So what does that mean? It means instead of thinking as, okay, I'm going to do a prototype and it's maybe goes into production and maybe not, think of a portfolio. It's just like a stock portfolio, right? You're not really counting on one stock to push your entire portfolio all the time over the years. You need a portfolio of stocks, guard against certain types of things, and that allows you to go from what you can think of strategic option value to a dynamic experiment-driven investment that has explicit, I'm using options as a metaphor, okay? Not literally saying go invest in options or something, or use options, but the option mindset is a mindset that you can use from an economic model perspective when you're dealing with agents, so that the investments you do in agentic AI resemble options. Small initial bets, options are bets, right? That open up future higher value opportunities. You have to have a portfolio of these small bets. Some of them will fail, some of them will succeed. And that's what ultimately your investment portfolio as options in agentic AI will allow you to push forward. Okay, and then finally the 10th one is kind of this agentic S-curve pattern. So we know that ROI follows an S-curve. There's usually a slow start, rapid middle, and then plateau. However, the reality with AI is that that slow start is kind of like the opposite. It's like 0 to 60 in like 2 seconds with AI, right? The time for AI is very, very compressed. Usually things take years and years. With AI, it's like 2 months, things are obsolete. So there's a weird it's an S-curve, but it's a really weird, tight S-curve that you need to be thinking about, a different kind of S-curve, which is maybe not such a slow start that is traditional. It's a very fast start, very volatile middle, and then there is obviously a plateau. So if you look at it in a little bit more detail, the classic S-curve adoption, the returns initially are very underwhelming, then gradually as inflection points are achieved, there are complementary investments that take, and over time, you can see the entire portfolio rise. So the ROI that boards are expecting, every board member is saying to their C-level executive, infuse AI into your products. You're like, I don't even know what to put in, right? It's like, what do I do? And then they go back to their VPs, like, put AI into your companies. Okay, and the VPs go down to their directors. There's a colleague there, very beautiful presentation. You were talking about the hierarchy, right? To use your model, if you go through that, it gets pushed down to the worker, because like, okay, what do I do? Okay, I'm going to do this today. So it's not a very well thought out strategy. Infusion of agentic AI, infusion of AI actually happens to happen at the top level of the company. And it's not that we shouldn't get feedback from bottom up, but it's like you can't just push this thing, you can't shift down this investment opportunity. It has to be something that's planned at the top, executed with feedback loops. So that's a really weird S-curve. So these are 5 domains of economic impact, and someone's going to kick me off the stage very shortly. Nobody's here, so I'm just going to keep rambling. There are 5 domains of economic impact. One is the labor and workforce, so digital labor, elasticity, and skill-based augmentation patterns. There's cost and compute, so you add compute as labor, usage-based inflation. And then there's capital and investment, so options and the S-curve. Organization and governance is workflow recomposition. Remember, doing things, it's not just replacing humans with agents. That's wrong. There's always going to be a governance lag. Make sure you're monitoring the agents. Platform and market structure. So consolidate your platform, build key differentiation in your domain, and then do complementarity investment. So there is a strategic horizon. So labor is going into intelligence arbitrage, where economies will compete on the density of intelligence that is available to them, that the tasks are able to be accomplished. So you're going to need to leverage a hybrid human agent intelligence with some kind of recursive, adaptive feedback loop that is optimizing across your company. I'm going to pause there, and if there are any questions.
I think for improvement for absolutely bonkers, I think my question is, in the long term, do you expect it to go down, to normalize, to be closer to the margin that we have today? Where do you expect it to go?
I think it's going to be. It's okay. Yeah. So. To summarize and distill, let me see if I got that right. What do you expect the economic outlook to be in terms of acceleration of ROI? Or if you want to rephrase that.
Yes, and impact margins.
Yay, we have a microphone. Awesome, thank you so much.
ROI, yes, also impact on margins long term, right? We are at the zero cost SaaS software world. We're still there. I know we're moving out of there. And then we are moving towards this really high compute for digital labor. I love that term. Where do you expect in the long run the compute costs or the cost of the digital labor?
Yes, cost for training, we just have to eat the cost for training. Cost of inference is going to go down, down, down. Using these systems, the cost of utilizing these systems will definitely be going down. Like, for example, at Google, we have an optimized infrastructure. We have our own chips. We have our cloud. We're constantly decreasing the cost and then transferring that decrease to our customers. So customers get better and better and better prices. That's the trend that we see.
Understood. Thank you.
Yes, you're welcome. Question here.
Hi, thanks for the time. You talked about, agents need to be able to resolve conflicts. They will get into disagreement. They might have old data. They need to have some sign of credibility of information they're looking at. So I'm curious, who is building that infrastructure or facilitating that?
Yeah, usually there's, in game theory, so the science to look for is in game theory. This is a known problem in game theory. So basically, I'll give you a very naive first response, which is you average. So if I send agents out to sense the temperature in this room, it'll be different. Near the lights, it's going to be high. And the agents are going to debate, no, it's 110. No, it's not. It's like 72 here. So you get an average, and so the average is an actual, relatively accurate temperature. The room isn't on fire, so the fire alarm doesn't go off. So there are techniques, like for example in game theory, that we need to use in order to answer these types of questions. That's like 60% of the answer. The other 40%, I would ramble all day, but happy to hit me on LinkedIn. I'll give you a more detailed response. Thank you. Great point.
I love the idea of using an options mindset and making those small bets. But when you're making the bet as a company to say, let's put the time, energy, and investment to build this out, what are guidelines that you use, especially if you know the domain, you know the data that you have, but you're not sure what questions you want to answer?
3 things. So number one, where is the most massive amount of time spent? Like if I'm a junior, not even a lawyer, I'm a junior legal, worker at a law firm, where do I spend 70% of my time? In researching the different cases and trying to. So an agent would really help me decrease that 70% down to 10% of my time. Boom. Now I can learn, So number 2, what moves the bottom line for the company? Meaning, how can the company be differentiated? 2 minutes? They're telling me 2 minutes, yes? Or you're just scratching your head, sorry. Okay, he's just scratching his head, that's okay. I've read too much into that. So second one is what will move moving the bottom line in this era means domain-specific agents, meaning in your industry, to be differentiated, you need to use the data in your industry, data that is kosher, data that is not pulled from weird places, data that your customers, or is your data, and therefore you can train on that data yourself or tune on that data, domain-specific data. And then third, to improve and delight the lives of your customers. Whoever you're serving, if you elevate them, that's going to definitely take. So I would invest in those 3 areas. You're welcome.
Hey there, how do you scale AI agents? Like, their information is always going to be needing an update or refresh. So if you're selling an AI agent to a customer and they go through an upgrade, their products change, how is that scaled?
Yeah. This is a very well-known problem in machine learning, traditionally. So we have this notion of a data distribution. So your information, like how many customers you have at different hours per day, let's just say it's that. What are the buying patterns of these customers? They have a specific data distribution. You know that distribution, but that's time-bound. It will change next. Moving into Black Friday, it's going to completely change. Moving into the summer, it's going to completely change. Some of them are seasonal and predictable. So basically what you need is like based on those anticipated seasonal changes, or just very, if I would use a very naive approach, I'd say every quarter, sorry, I'm going to go reassess the data distribution, make sure the input distribution of data and my test data that I'm training tuning or testing my models on rather, matches the initial data distribution that was used to train them. If that test data distribution, sorry. An agent couldn't have done that. An agent couldn't have picked up a bottle of water. They would just gone talking. So the idea is that you're essentially obtaining information, training a model. Now, periodically, every quarter, you're going to test that model with a new distribution of data that you have for that month, for that quarter. If the model diverges, If the accuracy, let's say, of that model starts to go down, boom, I need to retrain or retune the model. So it is a very well-known problem in machine learning that data distributions will change over time. You take your test set, you get the new data distribution against the test set. If the metrics go down below a certain threshold, you redo with the new data set. It's like a super well-known thing. It has nothing to do with AI or generative AI. It's just statistical machine learning has been doing that for years. But it's not something that businesses have been doing, right? That's the surprise for people. I hope that helps. Yes.
Yeah.
There's a gentleman here. Oh, no. Okay.
Quick question first.
Yes.
Yeah, thank you so much for the presentation. That's pretty awesome. One of the slides you said, I'm just trying to read it, agentic AI ecosystems favor integrated stacks. Could you...
Favor what? Sorry, say again.
Integrated stack?
Yes. The integrated stack would be, you have all the way from, okay, I'm going to make a very biased Google analogy. So we have TPUs, we love NVIDIA. NVIDIA is our partner. We have GPUs. We built TPUs that are even more efficient. So that's the bottom of the stack. On it, we have a compute layer. On it, we have a Vertex AI layer that does all our AI. On it, we have applications. And then you can create applications. You can tune models on top of that. It's a vertically integrated stack because all these components work together and have an optimized price structure that can be given to you. If you need to, you can go out and shop for the very same thing that works for you. Maybe you want some specific type of model that is not available, let's say, on a particular hyperscaler. You pick and choose that vertically integrated stack. On top of that, you create domain specificity, domain-specific models, agents for you, and that becomes your integrated stack with key differentiation for your company. Great question, thank you.